This talk was presented at Google I/O Extended Grand Rapids in 2023.
I'm Joe Lust, and I'm here to talk about lightning fast web apps and how we can really harness the cloud and especially serverless to make things faster than ever and easier. So about me, sometimes of the year I have a beard. I'm also a cloud architect at Mabel. That's what I play by day. And I'm a massive fan of serverless. I use that every day in my commercial work and in my personal work. And we'll talk a lot about that here today. I'm also a Google developer expert in cloud. So they were happy enough to help pay my way to come and talk to y'all today. I'm also a cloud innovator champion, and I have 2 certifications as a professional cloud developer and as a professional DevOps engineer. So hopefully I sound like I know what I'm talking about. Another thing about me, though, a fun fact, I like llamas. Llamas are really awesome. I actually helped train a llama once in an obedience course. That's where I took this photo. And since we need to talk about AI and ML, llamas are really cool too. I don't know if you guys know about the llama model. You should probably listen to the cool announcements today at I/O. We'll come back to llamas. That's not just a random thing. So let's talk about apps. You guys are probably folks that build apps, I suspect, things that do stuff. So just curious, has anyone here made an app before? Okay, so you guys are probably going to know what I'm talking about here. Excellent. Thank you. Thank you. Apps are also what pay the bills for the rest of us, so that's very convenient. So we know that apps do something, right? They need to be useful or people wouldn't be paying us to build them. Sometimes that's business value. Sometimes they're just fun, right? Something entertaining. Sometimes they serve a public good. Maybe you're helping out a hospital or, local library. Or sometimes they're just thoroughly inane. I don't know if anybody had the Yo app from a few years ago. You could only say one thing, and that was Yo. That's the only message you could send with it. Really cool app. We'll focus on some entertaining apps here. And while I'm thinking about it, a great app to have, I think, would be something llama related. So we'll keep this llama theme going. So we're going to make apps. Apps are useful things. We got to put them somewhere, right? We need to host this stuff. We need to give them a home. And so where are we going to put our llama app, right? Because our llama app could take many forms, right? It might be on mobile, desktop. It might be on a watch. So we're going to send all that data to the cloud. And it's going to let us organize and put a backbone to our app. Let us do distributed things, serve content, store data, maybe even run fancy AI and ML APIs that are going to be announced today. Maybe. But we need someplace to do that, right? And that's where the servers are going to come in. Now, show my age. We could talk a minute about physical servers. Has anyone, I'm just curious, another show of hands, has anyone here ever actually touched a physical server? Wow, okay. So you're about as old as me then, that's good. This is a thing of the past. You don't need to touch servers anymore, but just so folks know why serverless is great, you have to understand the servered world we all come from. So let's say at your company, you want to deploy a new app, then that requires a server, right? Are you going to start next week to think about the app, or maybe you're going to ship the app next month? Well, in my experience, it was more maybe next year, right? Because we're going to need to get budget and get budget on the budget. And then we're going to need to talk to the provisioning, team. And then, Dell's going to have to give us a quote that they're going to mark up. And then our negotiating team is going to really work with them. Sales is going to work with them, purchasing, and then they're going to mark it back down. And then, we're going to get that allocated. And they're going to finally ship them. And months from now, we have servers. But you got to give your servers a home, right? And if you've ever been in a data center, it might sound cool. You see these pictures, in marketing materials, blinky lights. It's not that cool. It's actually hot. It's very hot. It's noisy. It's, humid. It's just, definitely loud. It's not a great place to be. And then you got to rack and stack those servers, and they're heavy. They're actually sharp. So this is the sort of thing I've done before. I've been clawing around inside these racks. I've been stacking these machines in here, and that's no fun. And once you get servers, that's not the end of it, right? We need to set up the networking, the software, security, everything. And this is what you do before you can write one line of code. Well, that's the old way, right? So I think you get the idea why maybe it'd be nice to be serverless. And Google Cloud, which is where I work most of the time, doing my professional code making, they have a few great approaches for this. They have Cloud Run, which we'll talk about in depth today, and Cloud Functions. And the beauty of this now is you can just supply perhaps a few lines of code. And now you've got your process out there and running to serve your apps. Now, that's not 6 months of POs and budgeting and clawing around in racks trying to put together computers. It's just one click, deploy that code. That's the beauty of it. And there's no servers to maintain. You only pay for what you use, which is probably the best part of serverless. I don't know if many people think about this, but you only pay for what you use. So like in Google Cloud Functions, for example, you can run 1 million function invocations for like $1, right? So I moved my email. My email server that I get all my email from the last 10 years is on a function. And I've paid like 0 pennies for every email in total that I've gotten in all these years across like 20 different domains, all because you can pay for just what you use and it scales to 0, right? So if your customers aren't using your app at midnight or 2 a.m. or whatever, 0. If you've got that wall full of computers I mentioned a minute ago, they're humming along day and night, right? They're pulling power, they're having to be cooled, guarded, all of the above. With serverless, it's only what you need when you need it. Scale up, auto provision, scale down, auto provision. As a quick example of that, where I work, sometimes big workloads come through. So there's a cloud function that goes from 0 instances to 30,000 instances to 0 instances. And just pay for exactly what you use. It's very beautiful. And that's really the modern approach we're talking about today. Oh, and sorry, there's one thing I didn't mention starting. If anything you think I'm saying is untrue, please shout out. If you have any questions, please shout out. And if you think I missed something, feel free to throw it in, please. So one thing about serverless that I want to talk about here is containers and Cloud Run. So has anyone here actually used Cloud Run by chance? Okay, Alex has used it. We got a few folks. The beauty of it is all it needs is a container. That's it, just a container. If you can make something work in Docker, it's now a web server. So if you want to make some Node.js code work, okay. And if you want to make some Python code, that's cool. And if you want to get your AS400 mainframe code from 1972 to run, you can do that too. Everything that can just listen on port and send bits back and forth can become a web server. And you can run that container on your local workstation, on your MacBook, or you can run it in the cloud. So easy to go back and forth there. They even have a mechanism, though, if you don't want to make a container, they can handle that too. It's called build packs. And it should say one click, not on click. One click provisioning and deploying, and we'll show that in a second. And everything else, like the load balancing, traffic splitting, moving traffic from your new version to your old version, all that fully managed, fully instantaneous. So, if you want to get to that continuous delivery and deployment that Carlos spoke to, it's so easy to do with tools like these. And a part that I'm going to harp on here in a second is that you can deploy this to 38 locations globally. So if you want to send the code to Ohio, you can do that, and you can send it to Iowa as well. But if you want to send it to Osaka, and you want to send it to Doha and to Melbourne, you can do that with one click as well. That's the really cool part here. Okay, so I said we want to build high performance apps, right? What's the high performance part here? How are we going to actually make your apps faster? Well, first I wanted to start with why is it important to make them faster. And so this is a quote from Google as official documentation, who said that 2 seconds is the threshold for commerce website acceptability. Websites, people buy stuff. At Google, we aim for a half second internally. So they're saying if someone comes to your app, to your website, and they got to wait 2 seconds, they're not going to buy what you're selling. They're just going to go somewhere else, right? And this isn't like a newfangled, really fast, metric. This is 2010. This is 13 years ago. We needed your app to be that fast. And so I'm just curious, has anyone recently tried to use a website or app that took more than 2 seconds? Right? Yeah. So I find myself, I'm like, well, load, refresh, F5. Okay, I'm going to the other place, right? I don't know what you're selling. I'm not buying it because I had to wait 2 seconds. That's why performance is important. And a great way, if you want to try to distill more of this, is Google's core Web Vitals. They've laid out a whole framework and tools to test all of this. And here's some numbers I pulled out from that, where they're saying that the largest contentful paint, right? That's basically the center of the page, right? If you go to YouTube, the contentful paint is when the video appears. Because I'm sure you've seen some of those apps that are rather annoying where they load and just a bunch of shimmering squares keep shimmering. And I don't know, you can't actually do anything. They're just shimmering. It's a cool CSS effect, but until people can actually use what your site's for, they're not getting any value out of it. And they're showing you that to be good, you want to be less than 2.5 seconds, right? And the second important part, though, is the responsiveness. And they're calling that the first input delay. When you click, it better do something in 1/10 of a second. You expect that responsiveness from the apps. And so how do we make sure that these apps are fast, make our users happy, and also to make sure we get put in search results? Because Google realizes that people hate slow websites, so they don't put them at the top. If your website gets slower, it gets dropped down. So you want to stay at the top and be useful, we got to go up. So what makes a slow app? Well, a bunch of things can make things into a snail. For example, slow servers. That's a great one. If your servers are far away, if we're sitting here in Grand Rapids and our server is in Doha, Qatar, then we're going to have some slow performance, right? And if you're not using caching headers, if you're not using CDNs, it's going to be slow as well for loading things we don't need to load. And something we're going to get into in a second here, single page applications. Giant bloated single page applications can really cause challenges. And I don't know, has anyone ever used React? Yeah, okay. React's all the fun these days, right? It's the cool thing. And this is how we build single page applications, right? When you go to a website and it loads and then you keep doing stuff, but it doesn't reload the website, it can do stuff really quickly, right? And that's because in the browser, we're going to do everything in JavaScript. We're not going to go back to the server. We're just going to do everything, render all the HTML interactions, do that in JavaScript. We're going to render the page locally because the time to go between your computer and your computer is 0, right? Very fast. And if we need to do something dynamic, we'll go back to your server with an API call. So this is a great way to do stuff. React is used by so many companies, my own employer included, but it has a minor challenge, and I'm going to show you that challenge right now with an example. So I can't hide the name of this website, but I won't say it out loud because I'm not trying to shame them. But I had to use it last week, and I was like, my goodness, this is not right. So we're gonna see how quickly this website loads. Here we go. All right, we got a blinky thing, but I actually want to book a trip. So all right, did they fix it? What the heck? Son of a, all right. 1 second, try to get out of the feedback zone. We're gonna try this again. I think I had something cached. I'll try this one more time, and otherwise I'll send them a case of beer to tell them they did a great job. Let's see. Go Gadget Copter. What I was going to show here. All right, well, they made it better. All right, good for them. What I was going to show is normally, including last night, this website would take 30 seconds to load. And the reason for it was that they used to have, let me close this panel here, a file here that was a 19 megabyte JavaScript blob. And it was being loaded from Amsterdam. And it meant that the site was really, 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 really slow. So they're undermining my argument here, but you can still see that it took us, we'll scroll down here. It still took, we got to go to the left here, 8.11 seconds for the site to load, right? 8.11, still not too fast. I was hoping to show you 30. And it still had to load 100, it's kind of clipped off the bottom here. I'm sorry, you can't see on the screen up front. It's made 99 requests before it could show you the login prompt. It loaded 48 megabytes of JavaScript, and it took 8 seconds. So this is what we're kind of trying to avoid. But why is main.js, that's compressed for, it's 19 if you decompress it. Why do we need 19 million characters of JavaScript to draw this form, right? Like we could send a picture of this in 1/10 the space. So let's see if there's a better way that we can do this. I tried recording as a video last night and it was just a black square. Oh well. So this is what we were supposed to see there, was 13 seconds to load that file. But the whole point is, this is the challenge with single page applications. You start building it, and eventually the reason that that form to log in takes 30 seconds to load is it's not the form to log in, right? It's everything that company ever did, right? It's the form to like add some feature no one knows about. It's the form to rename your dog's, flight booking. It's every one of the hundreds and hundreds of workflows in that app has to be loaded before one thing can be done. And that's the challenge with SPAs, is that they're not really kept up well. Everybody puts all their logic and code into your React app, and it just gets bigger and bigger and bigger and bigger. And now that time to get to your site, if you were going to that site to book a flight and it took 30 seconds to log in, you might just go somewhere else, right? So these are some of the things we can try to improve. And we'll also not store the files for your app, 6,000 miles away. And this is one of the cool new technologies that we're going to be using here, which is called server-side rendering. It's kind of the inverse of single-page applications. Now, you might say, Joe, rendering the HTML on the server, that doesn't sound brand new, does it? That sounds like 1997, right? That's how we always made web pages until we had single-page applications. And that's true. But a few things have changed since the 1990s, when we had to use ASP and PHP and JSP pages, for example. One thing is that now, I don't know about y'all, but I got a 5G connection in my pocket, right? And I have a 1200 megabit per second fiber connection in my house, right? The internet is way faster now than it used to be. And servers are way faster than they used to be, right? You can go buy a server with 256 cores and 4 terabytes of RAM, and each one of those cores is faster than the server you got in the 1990s. So the server can do and render stuff very fast, and the internet is now very fast. And remember how we said serverless could deploy globally? Well, if we put your app in Toledo and in Toronto and in Iowa, now it's within like 100 miles of all your users here, right? So now that that round trip time is like 20 milliseconds, right? And 20 milliseconds, if you remember, is about what it takes for you to blink your eye. So now we can actually render things on the server, and we can send them back lightning quick to your browser. And it's actually a lot faster than loading a 19 megabyte JavaScript waffle, And there are a few frameworks out there. I don't know if folks have used them yet. There's a few rules, though, if you want to make a server-side rendering library. It has to be 4 letters. It has to start with N. It has to end with T. So you might have heard of some of them now. We saw some names pretty soon. But there's Next, and there's Nuxt, and there's also Nest. Easy to get confused at the conferences when you go to these. And finally, I just wanted to note that you can have the best of both worlds. You can use the SPA, the single page application, for the deep, interactive parts. Maybe you've got a canvas and people are drawing things and making maps or something, real hardcore UX. And then you can use the SSR for the first impression when they come to your site, when you need them to not leave and go buy your competitor's product, for the login page, for the sign up form, for maybe your marketing landing site, and then you can transition them once the rest of the stuff's loaded to the SPA logic. You can fuse these together as well. So how do we really make the most of this, though? We want to be hyper local. So let's say we're in Europe. We got a product, we're selling it in Europe. And, Google happens to have a lot of data centers in Europe. So we'll use those. And we have to think, where are these customers of ours? Well, we've got, some of our Llama friends down in Spain and in Austria. And we got a data center for them. And we've got some, Swedish and, Lithuanian Llamas as well. And finally, we might have some Irish and German Llamas. And we can make sure that each of them is served from a data center that's nearest to them by just deploying, to all of them. And that might be hard in the old days, but now with serverless, and we'll show in a minute, literally one click to send it, we can do that pretty easily. And as we said earlier, now you're so close to people, the equivalent in the US of being like within a state or two, that you get like very fast, 20, 30-ish, millisecond round trip times. And if you're also in some other countries, they might like to have their data kept there. For example, with data sovereignty, you might have heard recently that Canada maybe wants Canada's data in Canada, right? So maybe you need to start, putting things in the Vancouver and the Toronto data center and in the other US data centers. So being close to the customer, to the end user, is actually something that's probably going to be more useful as compliance type laws come into effect, things like GDPR in Europe. But let's dive in with a demo. I always like to say, show them, don't tell them. And I'll note that because this is serverless, you guys could do most of this at home for $0. So I mentioned with Cloud Run, we're gonna jump into Cloud Run in a second. All we need is a container, right? So this is just an excerpt from what I'm gonna run in a second. And we're just going to take Next.js and we're gonna build a container. And we're gonna put Next.js in it. So here it's pretty simple. All we need is Node.js. We're gonna use 18. Alpine is a version of Linux. It's very skinny, makes a very small container. And we're just gonna pull in our app and we're gonna, npm CI, get the dependencies, we're gonna build it. So show that in a second. And a cool thing here is that, we can just make our little Docker file. And all we're doing at the end here, right, is we're just saying start node, piece of cake. Is we can actually use cloud build. So I'm going to fire up cloud build and I'll talk about it in a second. And cloud build is a CI/CD tool built inside of Google Cloud. You basically get it for free if you're using anything Google Cloud. And if your CI/CD is running in Google Cloud, if the place you're deploying and the place you're pulling from and the place that you're keeping your Docker images are all in the same network, then they're all running at like 1 to 10 gigs a second, right? It goes wicked fast. There's not a lot of the stuff you see when you're like using GitHub Actions and you're like, okay, push my image for the next minute and a half. No, now you push your image in a few seconds. But all we're doing here, this is actually the complete build. We're just saying use Docker, build my image. And by the way, the app we're building is Llama based. This is Llamaland. And so we're going to build the Llamaland image and then we're just going to push it. And we're pushing it to Artifact Registry. It's like the private Docker repo that you get inside Google Cloud. So we'll see how that went. So I just submitted it a minute ago, and it's in the middle here. It's running through our build process, making our image. And we'll look at where that's going. I told you it was going to Artifact Registry. So here's our Artifact Registry. And it's got all of my images. This is for the Llamaland product. And you can see I ran it this morning. And in a minute, it'll pop through. Well, we'll just see it. It'll finish in just a second here. It's linting, checking. It's going to compile all of our website in a second. And then it'll be pushing it out. Code always compiles slower when you watch. When you don't want to ship it, it just flies right by before you can hit Command C. All right, there we go. And we just finished building our whole static website. We're going to copy it into our container. And here we go. We're shipping it. And there it is. Done. So now we'll go back over to Artifact Registry. And there we go. Just now, there's our brand new Llama image. Cool. So we've got our app. It's a SSR, a server-side rendering app using Next.js. It's now been built, and we got a container. So I told you it'd be one click to deploy. So let me see if I can come true on that. So we're going to use the gcloud utility. I don't know if anyone's ever used that before. It's the command line interface for Google Cloud. And you just type gcloud run deploy. That's it. Gcloud run deploy. Piece of cake. Here we're going to try to go Llamas worldwide. We're going to send it to US Central. So that's what this line says. Allow unauthenticated. This is on the public internet, so let anybody come and hit it. Minor programming note, we're not using HTTP2 because Next doesn't support it. And here's the image we just built, the Llamaland latest. So let's do that. This is a great utility. If you've ever used anything Google Cloud, by the way, this is called the Cloud Shell. So if you're at home or you're anywhere else and you want to make sure that all your shell stuff works right, I just click the top corner here, and I'm in my shell. Got all the stuff I need, and it's in the cloud running at gigabit speed. And it's great when you're in a demo here when you want to make sure nothing goes wrong. So let's see here. US Central. So here's my command, and I'm gonna make this a little bigger. Hold on. So this is the command I just showed you a second ago, and we're going to send it to US Central. And US Central is in Council Bluff, Iowa. Council Bluffs. All right, so now we got spinny things. That's always good. And all right, we're done. We just set up our serverless stack, our cloud, the instances of it, set up all the networking, cut the traffic over, and it's live in Iowa. So let's go look at that. I'm going to make this a little smaller because that was too big. Okay, so here's the one I just deployed to US Central. Oops, I realized I misspelled that. But there you go. And this is what it looks like for our app we deployed. And we actually get metrics. So we can see, how much CPU is being used, bytes in and out, how many hits it's getting, how long it's taking for these requests. You can see the latency here is actually quite low, right? It's kind of like so low, mostly we can't even read it in the chart here. But let's go and let's just go see how things are doing. So here's Llama Land, and this is our SSR, our server-side rendered app. And so it might look like a static site, but when I go into stuff, and that loaded instantly, we'll just note, like that was like a few milliseconds, right? It just went out and it got more stuff and it came back. It got another web page and showed it. So we can learn about a lot of our favorite llamas here. This one's named Mocha, by the way. And we can just keep going through and perusing all of our llama content. But all these pages are being fetched dynamically. ChatGPT might have written the content for this blog. But we get a very responsive, very quick app. And it, again, is just being served like a 1996 web page, but very, very quickly and hyper-locally because, Council Bluffs, Iowa is not that far from where we are right now. So one other thing we can do now is we can go through in Cloud Run and we can set up DNS and that sort of stuff. That's managed here too. So we've gone and set up llamaland.dev. So actually now we have our full website, llamaland.dev, right? And how is that being bound to our app and where our app's being deployed? That's all fully managed for us. If you want to go and read about llamas, it's available right now at llamaland. That's it. There's a dash in there, llama-land.dev. But again, that's fully managed for us. And I mentioned there's traffic splitting, which is a really cool thing. If you actually push out multiple versions of this, you can say this one gets 2%, that one gets 20%, and this one gets the rest. So you're doing that continuous deployment. You can actually say, okay, do the staged rollout, all that. And that's just one command, fully managed in there. They'll drain it, lift it back up, and so forth. And it gets better still, though. So let's say, llamas are an animal that's found around the world. So what if you're in Oceania, right? What if we want llama land in Melbourne? Okay, well, we can do that. How much more work do we have to do that? We'll pull our shell back up. We just need to change one line here. So here's where we're sending it to. So here is our US Central one, right? So we'll just go in here and say US Central. We're just giving it a new name and we're sending it to a new place. Let me deploy this to Australia. Okay, well, we got spinny things. That's good. And it's been, we've got the new policies set up. We're making the service. And it should start routing our traffic here in a second. Australia is really far away. And sorry, this took 1 second this morning. The demo gods. Sometimes things may take a few seconds, unfortunately. Don't watch me. What we should be seeing here is that this happens quite quickly. There we go. Now we're deployed live in Melbourne, Australia. So if we went to watch our llamas in Melbourne, clicking that link, it would be served from the opposite side of the earth, the antipodes, as they say. But if you're in Australia, you're going to have way less latency. Because I don't know if you guys ever had an app and you start getting customers where you didn't think you were getting customers. We have a ton of customers in my company in Japan. And sometimes they say, gee whiz, America's far away. It makes things slow. Can you guys deploy stuff over here in Japan too? Well, if you wanted to deploy your code to Japan, that's it. It would be an agonizing 45-second wait, and you could have it too. So literally, it's just editing that one line to send it to a different part of the world. If you wanted to say hello to Finland as well, we could just edit that again. I'm fearful that Finland's too far away, but you know what? I'm feeling lucky. It's going to go faster this time. Totally going to go faster. So we'll try removing that line. All right, let's see if it goes faster. Finland's like totally closer than Melbourne.
Is it possible to have one deploy and you assign it to multiple areas?
Not yet. That's not like a built into their SDK. You know, I usually just have like a bash file that says like, hey, just run these 20, and then boom, it goes out there. But it's not like a single flag. Right now, you deploy it per region. Yep. And there we go. Now we're live in Finland. Unfortunately, though, another 60 seconds of agony up here on stage. All right. So trying to pull together what we're seeing here, what I'm selling, the big picture. You got llamas everywhere. I mean, you get users all over the place. And using some of the cool tools here in Google Cloud, like the Global Load Balancer, which we didn't get into because it's a little bit more complicated, you can make one website, llama-land, you know, llama-land dev that I just put together. And if you're coming from Australia, you go to the Australian endpoint. And if you're coming from Finland, you go to the one in Finland. If you're in the US, you go to the US one. And that's all seamlessly managed for you. And all you got to do is just deploy to Cloud Run. And you just stack those up, and it's going to be distributed locally to the nearest endpoint for your end customer. And that's going to let us do things like server-side rendering, which we are going to use for your fast dynamic content. You know, basically, you know, showing people that login form, showing people that sign up form, showing them that first impression that they're going to get of your web property. Meanwhile, we can use other tools like Cloud CDN, which we didn't show in the demo, but it's pretty easy to set up. And now you're going to get the hundreds of worldwide edge nodes that are going to serve your static content, like your, you know, SPA, your single page application. So you can basically, use the union of these two for the complex needs of your application, and then those first impressions. Have a good, first impression, better second impression, and you can do all that being hyper local to your end users. They're going to get that high performance. Because again, your customers are worldwide. When we put things on the internet, everybody on earth actually does get to play with them, and you never really know where your app or your service is going to blow up. So as we saw, you can deploy to global regions in seconds, sometimes 12s of seconds, but still pretty quickly, way faster than if you're doing it the old-fashioned way. And we can minimize latency, we can minimize load time, and we can maximize those web vitals that Google showed us are really important for people to enjoy your app, for your app to get highly ranked in the SEO, for people to even find your app, and to keep you from just becoming the slow alternate that someone wants to go find a better option. And finally, since we mentioned serverless here, I didn't show the rest of that screen, but there's a dozen places running this app right now. And I'm sure when I get the bill at the end of the week, it's going to be like 4 cents. Like, no joke, just a few pennies, because you only pay for exactly what you use. So you can basically afford to deploy it somewhere that's not being used, because if it does get used, you're just going to scale it up and scale it down instantly there. So that's it. That's my spiel. Thank you all. And happy to take any questions you might have about serverless and this sorts of applications.